So in this video we have an electromagnetic wave that propagates in the negative z direction. The electric field has a maximum of this, and it's in the positive x direction. And the wavelength is at 500 nanometers. So we want to know first what the frequency of the wave is. So I've gone over here and I've used the fact that the speed of light equals the wavelength times the frequency. So I know the speed of light is a constant, and I have plugged in the wavelength provided, converting it from nanometers to meters, and I have solved for the frequency. Part B, I want to know what the maximum strength of the magnetic field is. So since I know the electric field and I know the speed of light, I can find the magnetic field. So I plugged in the electric field, and this should be volts per meter. And remember to convert it from millivolts per meter to just volts per meter. And then I have plugged in the speed of light once again. I found the magnetic field, which has units of Teslas. Now in part C, I'm going to know what the equation for the electric field vector is and what the equation for the magnetic field vector is. Alright, so the first thing I need to fill in is the fact that the wave is propagating in the negative z direction, so I put a z here and a z here. That means that this here is positive because we're propagating in the negative z direction, not the positive z direction. Alright, so I was given the field strength in the problem, and then I found the magnetic field strength down here. Then I need the wave number. The wave number is calculated by 2 pi divided by the wavelength, so I found that here. And once again, we're propagating in the z direction. And then I need the angular frequency, and the angular frequency is found by multiplying the frequency times 2 pi. And we found the frequency part back here in part A. And then we would multiply by t here. So the last thing we need to figure out, we were told in the problem the electric field was in the positive x. So the last thing we need to figure out is the direction of the magnetic field. That means I'm going to point my thumb in the negative z direction, so into the board. My fingers are going to point in the positive x direction, so that means I need to grab the magnetic field that is going, so my fingers curl and grab the magnetic field that is going in the negative y direction. So that's how we get that this is both negative and in the y direction.